All right, so now we're moving on to chapter 4. Okay, so we'll start part of chapter 4 today, and we'll continue tomorrow. All right, so all right. So hold on 1 second. Share screen. Okay, chapter 4. Okay. Tissue. Okay. Tissues. Okay. So our cells, we have trillions of cells. So our cells do not function independently of each other. That would make no sense. Our cells actually have to function together, and therefore they work in groups, and those groups are called tissues. Okay, by definition, a tissue is a group of closely related cells or associated cells that perform related functions and that are similar in structure. Okay, there are 4 basic types of tissues and basic functions. Okay, number 1 is epithelial tissue. Okay, we will cover epithelial tissue in chapter 4, this chapter, and the next chapter, skin, chapter 5. Okay, connective tissue is for support, and we'll cover it basically in chapters 4, 5, 6, and 9. Okay, and you'll see like why. Muscle tissue we'll cover in chapters 10 and 11, and then nervous tissue we'll cover in chapters 12 to 16 and chapter 25. Okay, so muscle tissue is for movement, and then nervous tissue is for control of the body. Okay. Okay. Epithelial tissue. Okay. Epithelial tissue, by definition, interacts with the outside world. Okay. So any type of organ will have epithelial tissue on the surface. Okay, on the innermost surface and on the outermost surface. Okay. So the epithelial tissue will cover body surface or line the body cavity. It will form parts of most glands, and I'll explain that in a little bit. Okay, the functions of epithelia, okay, protection, secretion, absorption. Okay, you think about it this way, epithelia is going to be the body surface, okay, or surface of the organ. And so the first thing that has to happen is protection from all the other stuff that's going on. Okay, and since it's also on the outside, it's going to secrete stuff and interact with the outside world. Okay. Okay, the special characteristics of epithelia. 1 is cellularity. Okay, epithelia have high levels of cells. Okay, so when you look at epithelia, this is epithelia, okay, as is this. What you'll see is cell after cell after cell after cell. There's no spaces in epithelia. There's no this stuff called extracellular matrix. Okay, extracellular matrix is this gooey stuff that's usually found on the outside of cells. In epithelia, there's literally very, very, very little extracellular matrix. Okay, what you see usually are 2 cells that are directly connected together, and they're actually hooked in together. And I'll explain why that's really important in a little bit. Okay, okay. So that's cellularity. Okay, so you see cell after cell after cell, and the cells are actually attached by specialized contacts. Okay, so there are different types of cell junctions, and we'll talk about how each one actually works. Okay, the third topic, polarity. Polarity means that a pole, like north and south pole, are different. Okay, in magnets, you have a north and a south, and those poles are different from the other. in charges, you have a plus and minus, and those things are different from the other. Those are polar. So polarity means that the cell regions are different. So let me explain what that means. Okay, so the top of the cell and the bottom of the cell are different. There's stuff like you can see all these little bumps. All these little bumps and stuff are only on the top. The bottom surface is smooth. The bottom surface is where also all the little connections are made. The top surface is not. So there's multiple surfaces to an epithelial cell. Okay, there's something called the apical surface. Okay, this is the apical surface. This is the basal surface. The basal surface will always attach to something called the plasma membrane, or sorry, the basement membrane, not the plasma membrane, the basement membrane. Okay, the apical surface will face something called the lumen, the empty space. So lumen literally means light. So when you look at tissue, you'll see the places where light comes through. That is the empty space. Okay, so if you think like a blood vessel, where the blood is actually running through is the lumen. Okay, it's the empty space. So the apical surface will always face the empty space. Okay. The next thing is the epithelial will always be next to something called connective tissue. Okay, the epithelium, because it literally has cell after cell after cell, it has no room for blood vessels to run through. So it's going to be avascular. A means without, vascular, blood vessels. Okay, the epithelium will receive nutrients from the underlying connective tissue. Okay, so you have no blood supply to the epithelium. They get their source of nutrients from underneath. Okay, they get their nutrients from underneath. Okay, so the blood goes through here and they get their nutrients from there. The last thing is this thing, the nerve endings. Okay, so even though they're avascular, they're very well innervated because they provide you with protection from the outside world. So they have to sense what's going on, right? So they have to feel pain, pressure, and all these things that are going on in the cell. Okay. Last but not least, regeneration. These cells are regenerated very quickly by mitosis. Okay, so we lose skin cells every day. Like if I rub my skin like that, I'm literally losing hundreds and thousands of cells easily, just like that when I rub. Okay, and so those cells have to be replaced, and they're replaced by regeneration. Okay. Okay. The classification of epithelia. Okay, the first name, so epithelium will always have two names. Okay, the first name of the tissue indicates the number of cell layers. Okay, so let me show you what that means. Okay, so I'm sure you guys can count. So there's a basement membrane. I'm gonna add, where's my little boxes? Box one. Box two. 3. Box 4. Box 5. Box 6. 7. Okay, so one single layer of cells. One single layer of cells. Okay, by definition, is called simple. Okay, if I have many layers of cells, actually, let me draw another one. 1, 2, 3, 4, 5, 6. This, multiple layers of cells. Okay. Okay. So one layer cells, simple. More than one layer, so 2, 3, 50, stratified. Okay. So now I'm gonna explain one more detail here. The word is pseudo-stratified. Okay, pseudo-stratified. Okay, pseudo-stratified epithelium. Okay, looks like this. Okay, I have one tissue layer here. I have one cell here, and here's my nucleus. I have another cell here, and here's my nucleus. I have another cell here. I have another cell here. I can even have another cell here. And I have the nucleus here. And the nucleus here. And the cell here. Okay. This is pseudo-stratified, because if I wasn't looking at this very closely, I would think there's one line of cells here and one line on the bottom, and that would make two, and therefore it will be stratified. But if you look very closely, every single one of these cells come all the way down to this membrane here called the basement membrane. Okay, every single cell touches the basement membrane. So in reality, it's only one layer, but it looks like it's more than one layer. So pseudo-stratified. Okay, hopefully that becomes clear as we talk about it. Okay, clear. Okay. Next, okay, the last name of the cell tissue describes the shape of the cells. Okay, so if I have a regular square-shaped cell, okay, they're going to be cuboidal, cubes, right? Cuboidal cells look like cubes. Now I can take this cube and I can do two things to that cube. I could flatten it, okay? If I flatten the cube, then I get squamous cells. Okay, if I take the cube and I elongate it, pull it out, okay, I get columnar cells, columns. Okay, so these are my cuboidal cells. Okay, if I flatten it, they become called squamous, and if I elongate it, they become columnar. Okay, the last thing, when we look at whether a stratified layer is squamous, cuboidal, or columnar, you always look at the apical surface, okay? Not the basal surface. See how these look cuboidal and these look squamous? This is squamous. So to classify this correctly, it will be stratified squamous. This would be simple squamous, okay? All right, so with that, I'm going to end today's talk, okay? Lecture quiz number 1, which you will take on Monday, okay? Will cover everything up to this point. So all the lectures from day 1, day 2, and day 3, okay? So everything up to this point. All right, have a nice day. I will see you guys on Thursday. All right.